Hello and welcome, ladies, gentlemen, non-binary, and wherever you are. I'm your host, Amelia Thompson with Würth Elektronik, and I am really excited about today's webinar. Joining me is Chem Sum. He's actually our European director, the head honcho, and guru of all things wireless power transfer. In just a moment, he is going to discuss the basics of wireless power transfer with We Cut the Cord. If you have any questions during today's webinar, go ahead and ask them in the questions box, and we will try to get to them at the end of the webinar. You can go ahead and say good morning to us to test out the questions. If you have any questions right away, we have a few people logging in here. We have some names that we have seen in the past. I see a Lucas from Florida. You are new. Welcome to our webinar. As I mentioned, if you have any questions, ask them in that questions box. Good morning, Michael. Hello, Nathan. And if we do not get to your question, we will answer them offline. You can email us at hereforyou@we-online.com. Now, as a reminder, because you registered for today's webinar, you will automatically receive the video on demand and the presentation slides after the webinar within the next 24 to 48 hours. Just check for them in your email. Also a reminder, register for our next webinar, again with Mr. Chem Sum. It is next week. It is actually the sequel to today's wireless power transfer webinar. Register online at www.we-online.com/webinars for wireless power transfer advanced coil knowledge. And of course, all of this is made possible by our exclusive sponsor, Digikey Electronics. You can find Wurth electronic components online at digikey.com. I'll now hand it over to Mr. Chem Sum presenting wireless power transfer.
Okay. So, hello and welcome from my side. Thank you, Amelia, for these warm words. And as mentioned, today in my session, I would like to present the wireless power transfer basics. We cut the cord. My name is Chem Sum. I'm responsible for the wireless power transfer topics. And for sure, you're welcome to ask questions to our chat function, and Amelia will take care of them. So today, first of all, I would like to go into the history. Wireless power transfer is not a rocket science which comes up in the last several years. No, Mr. Nikola Tesla, he started in 1893 just powering up light bulbs. Maybe some of you also get some pictures out of this in the web and find this. I'm sorry. And after around about 100 years, everybody of us knows these kind of electric toothbrush. So this is also powered by wireless power transfer. You have two small coils which are inside to each other, and you are charging the battery. Again, around about 20 years it takes place that the Wireless Power Consortium is starting their work. So that means in this time frame, nothing happens. But everybody knows there must be an other way to charge batteries beside you using an USB cable. Yeah, in 2011, the first Qi receivers are integrated into mobiles. Here in the picture, I just pick up one of them, and they are in the first 5-watt Qi receivers, including that you can charge your mobile. This charging devices really looks like in that way that you have your charging station, and then you're placing your mobile on top of it. In 2017, I think this was really the break-even point, as Apple is joining as the WPC and committing to using their mobiles with the Qi, with the WPC standardization. After that, for sure, everybody knows this comes into in all mobiles over the world. In 2018, I just picked up a nice picture of a BMW car, which shows in a video how to charge a car. That means we can see that it's going up the power levels from 5 to 15 watts, 50 watts, 100 watts, up to several kilowatts, which can be used in different kind of vehicles or applications. You can find on our website we-online.com or .de wireless power and very nice video. I don't want to show it today, as otherwise I don't have to do a kind of presentation. So have a look on it and you will get a 2 minutes video, and which will give you a very good and short summary of what we are able to do, what is wireless power, how it works, and gives you some kind of ideas what kind of capabilities we have at Würth Electronics. Today, I would like to show you some examples of applications where wireless power technology can be used, the different technologies and standards, how wireless power transfer is able to transfer the energy, which markets are coming up or which will go in the future. Important from our side for sure, the coil-specific considerations. The coil-specific considerations are very influencing the efficiency of the whole system. In the end, a little bit inside views of our products, advantages, and where you can find some information materials, design kits, and how to start up by yourself. Our applications. Beside all the consumer products, as we're talking about my mobile, which you can charge by a charging station, and you can just buy it and place it on your desk, for example. Beside that, as I mentioned, there are possibilities to charge in the automotive area. But here in this picture, you can see the automotive area charging a car. But also it's possible that you can do charging in your car, your mobile, for sure. Additionally, I'm standing here on my desk at my home office, and you can also charge your mobile maybe in the bus station, in the trains, in your meeting room, in hotels, anywhere where you have a place where you're waiting for something, and you're able to charge your mobile quite easily. And if we are today in the Corona pandemic, nobody wants to touch maybe the cables, you can directly place your mobile on top of a charging station, and it was completely without any contacts. For sure, for the medical technology, this is our focus topic for sure. All our a lot of our customers coming out of the medical area, as here we have products which can be sealed, which can also be disinfected very easy, and these are very, very important topics nowadays. Additionally, industrial rough areas are also one of our focus topics in our customers, which we have today. Is you can see here an agricultural robot. It's also driving around. Everything is wireless, sending data by GPS or Wi-Fi or Bluetooth. You have some sensors to measuring the temperature, ambient temperature, or the pressure, or what else. And when this is not done right now, or not so often, is that you are able to charge the battery wireless. For example, not a robot like this, or you can have a drone which is landing on a specific spot, is charging the battery, and then continue the work, whatever it is. One of our customers is Coil, and this is an example how wireless power could be. This is a sound processor which is placed on top of the head, and inside of this ring here you can find a wireless power transfer coil. This customized coil is transferring energy and data from the processor to the cochlear implant in the head of the person. Additional applications could be for more power. Out of this wireless power transfer slide, what I have copied here from, you can see it's quite a long time ago, but the appliances didn't change. So that means the 60 to 200 watt range for laptops, more for the robots, for the gardens, drones, power tools, or any kind of kitchen appliances which are needing more than 200 watts up to 2.4 or 2.2 kilowatt, which comes out of your household. These are the topics which the Wireless Power Consortium is working on to go through the standards. And if we have a global standard which is working in every country, you can use your mixer on the countertop in Europe, in Asia, or in the Americas. And I forgot to say, you don't need any kind of cables, and you don't need a different cable for Europe, an adapter for UK, an adapter for US or for Japan or anywhere. You don't have to need this. And the complete appliance is closed and you just place it on a hotspot. How this works? In principle, wireless power transfer is quite easy. It looks like a transformer, like you can see it here in the picture. This transformer is coupled over this ferrite core. And if we now just cut the transformer in two pieces, we will have a primary side and a secondary side. Or we have it anyway, but if you cut it, then you have a primary and secondary side, and the primary side will be our transmitter, and the secondary side is our receiver. And the transmitter and receiver coil are in the same range like the transformer, just we have a big air gap in between, like this distance. And between the transmitter and the receiver side, we are transferring the energy by magnetic field, which are inductive coupled. How this looks like? Inductive coupled solutions we can see on the left-hand side is a mentioned transmitter coil, and you have a receiver coil. In between, you have an air gap. The magnetic field is transferring the energy from the transmitter to the receiver side. So we are able to concentrate the magnetic field between these two coils. So all these are between that, and we control it, and the distances are very low. We are talking about between 0 or 1-2 millimeters up to 10 millimeters. The other way, it's possible to use a resonant solution. It's like a loosely coupled system. In this case, we have a transmitter antenna, which is distributing a magnetic field in a bigger room, and receiver antennas catching up the magnetic field and the energy. So it's possible to use one or more receivers at one time. They will sharing the energy, and for sure you can see here the coupling is not so good like here. So the efficiency is lower, but you have much more freedom in X, Y, and Z direction just to catch up the energy out of the magnetic field. This system is running at 6.78 megahertz, or also you can use it with the NFC frequency 13.56 megahertz, just up to 1 watts. Inductive coupled systems normally are, let's say, between 100 and 200 kilohertz. The car charging is defined by the SAE, and these are working at 85 kilohertz. Our next picture shows how this looks like. An inductive coupled system as an example, we have here from Texas Instruments an evaluation board, as we have the transmitter board. So this could be, in this case, an charging station included in this small box here, and this coil on top of it could be included in my mobile. Another solution you can see here is a resonant solution, which is working at several megahertz, and I have 1, 2, 3 different receiver coils which are catching up the energy out of this transmitter coil. Which standards we have nowadays and which are the most popular? I mentioned before the Wireless Power Consortium. This is the so-called Qi. This is the logo for it. Qi comes from the Chinese word energy. As mentioned before, the working frequencies are between 100 and 200 kilohertz, and it started with 5 watt, extended to 15, and higher power classes are going to be in this year or next years. There are a lot of products certified already, and it's really interesting in which direction it will go. And it is a closely coupled system. It's inductive coupled, as mentioned. But a loosely coupled system is from Airfield Alliance. The Airfield Alliance is a joint venture of the Alliance for Wireless Power and Power Meadow Alliance. These two are now merged to one standardization organization, and they are transferring energy at 6.78 megahertz. So this is the big difference. And also, which is important to know, is the data transfer here is an in-band, so including to this sinusoidal curve. And at the resonant solution, you need an extra channel by Bluetooth to transfer the data from the transmitter to the receiver or vice versa. But as mentioned, you have much bigger distances are possible and more X, Y, Z freedom. Important is, if you are looking into wireless power transfer technologies, why we should do it or why I should include it in my application or in my new product. First of all, you have no metal contacts. That's important because you don't have to, you have no claims on it, and there are no oxidations. So this is a very big benefit to seal a product. Second or third, there is a standard in the market. The WPC, the G standard, is used by 99% of all mobiles, for example, in the world. And it's a quasi standard for everybody who wants to use it. You don't have to do certify by G, but you can use the infrastructure which is still available, and a lot of IC manufacturers have wireless power transfer chipsets available. The interoperability is an important point, as if I have, for example, a Samsung or an Apple iPhone, all of them can be charged at the same station, and I don't have to choose a one, or I don't have to have different cables from a different mobiles or different devices. I'm just using one station. For sure, the safety is regulated by all regulation standards and included in the WPC standard specification. It's convenient, yeah. I can just forget my cable at home if I'm going to a business travel, if I'm going to privately holidays, and in the hotels, if there are charging spots in the lobby, in the room, everywhere, I just charge my mobile and I don't need any cables anymore. The integration of IoT is also possible. If we just think about applications where you need energy for the sensors, and the sensor is working maybe just independently and can send out this, but if you have, for example, a climate chamber and the walls are too thick, or you are not able to drill a hole, you can transfer the energy through the walls, and then the sensor is working and can also transmit the data over these walls or glasses, and then you can send over this data to the cloud and have the possibility to see this on your laptop, PC, tablet, or mobile device. What kind of markets do we have today, and maybe where it's going to be? Here, this is a very quite old IHS long-term future figures. As you can see, the transmitters and receivers which are getting shipped in up to 2025. And if we just believe that 2 billion of receivers will be delivered to the market, so most of them for sure are any kind of mobile devices, but also not 1 billion, what is that's wrong, but also the huge amount of 500,000 of transmitters, like charging stations for your desk or anywhere else. So it's a huge market. Nearly all global manufacturers of cars are supporting and adopting this kind of product and charging station in the car. So nearly all of them are having any kind of possibility to charge your mobile in the car, in the armrest or in the front for this. I believe in the future, it will be not only one charging spot in the car, maybe there will be 2 or 4, that everybody who's sitting in the car have the possibility to charge their own mobile. Now it's going to the next topic, to the coil-specific considerations. We have seen some pictures of the transmitter and receiver coil, but what is the best fitting or best coil pairing for me, and how can I find it, and what is important for me? First of all, use the largest possible coil which will fit in your device. We have to keep the distance in our eyes, that if we get the maximum efficiency and the best coupling, we can transfer the energy as best as possible. The misalignment should be minimal, as if we have minimal misalignments, the coupling is better, the efficiency is better. Choosing the best matching coil, that means you have to find out which sizes you have on your application, if you would like to go with a Qi solution or you want to go with a proprietary system. Important is also the parameters which are influencing the performance on the cost side. So if you would like to have high performance, high efficiency, you have to go with Litz wires and high performance ferrite materials. Is this needed on your application, or you just want to have a best in case? I mentioned before the positioning and the freedom and the minimal misalignments. If we look into an inductive coil pair, receiver and transmitter side, here we can just place one of them. Important is here to align them with ±5 millimeters. Yeah, this is defined from the Qi. If I need, for example, in the car, a bigger air just to use the armrest, for example, then I would like to place my mobile on that, and where I place it, the best coil which have the best efficiency or coupling will be chosen out of these 3. So I'm extending the X direction. If I would like to have more freedom, I have to make an array like this, and then I have an X and Y direction, the possibility, and the best fitting and best efficiency coupling coil will be chosen out of the system. For sure, as a manufacturer for components, we're super happy if you would like to realize such kind of array. That's clear. Now, if you're looking into the misalignment, I mentioned this several times now. What is misalignment? So we have different kind of misalignments. We have misalignments in X and Y direction, and of course also angular misalignments. These angular misalignments will have a big benefit or not benefit. If you look into the design, maybe you need an angular misalignment to have a better look on your display for the convenience of the product or what else. But this have, again, a not so good effect for the efficiency in the coupling. Here an example. We did some 2D FEMM analysis to show how the coupling is changing by changing the angular misalignment. If we have a transmitter and a receiver coil, and we look into a 0 degree. 0 degree means they are completely parallel, transmitter and receiver. Looks like that way. Now we are increasing the receiver side, and the angular is going in this direction. At the beginning, we have a coupling over 90%, 0.95. You can see the red curve. If we go down up with a misalignment of 40 degrees, just in the beginning, with the lowest vertical displacement, we have lost 50% of the efficiency of the coupling. 50% just by changing from 0 to 40 degrees. Because maybe the designer would like to have a better view on the display. So always keep in mind, work very in the beginning, work with the electrical engineer, mechanical engineer, design engineer. Everybody must be working on this and have everything in your mind. To increase the coupling, also we have a ferrite material in our products. Why we have it? So if we have a air coil, for example, in this case, the air coil have a field around it which looks like this way. So there is nothing which is shielding. If we have on the one side this shielding material, you can see that the magnetic field will be focused and concentrated on top of the coil side. Now, if we have a transmitter and receiver coil, the transmitter and receiver coil are focusing the magnetic field to each other, and the magnetic fields are running through the ferrite material and going out and going down to the next one. So you see as a on the left and right hand on the back side, the magnetic field is more or less zero. Now, as an example, I would like to show you how to choose the best coil fitting. Now, if you look into this example, starting with the transmitter coil. The transmitter coil is normally in the shape of 48 to 50 millimeters, so a standard charger, which I can buy at Amazon, for example. And if I'm now looking into which receiver coil I would like to use for. If I have a receiver coil which have 40 by 40 millimeters, so round about the areas are 1 by 1, the coupling is at 80%, 0.81. If I'm decreasing the effective area of the receiver by 20%, it looks like the right-hand side here, you see there are 1 to 2 the areas. That means also the coupling is decreasing from 0.8 to 0.6. So the efficiency in the end will go down by 20% because of reducing the area by 50%. If we look at now other way around, if I have in my application and remote control or what else, only just space for a very small part, it looks like this here with 20 millimeter outer diameter, and I would try to use the standard A11 or A10 coil, which is the standard in the market, you can see the coupling is super bad because the area is too big, the difference. So I have to choose a smaller transmitter coil that this coil will work. This 20 millimeter transmitter coil, you can use just 1 by 1 at the same IC, but it is not G certified. It is compatible, it works with the IC, because for sure the IC don't know the size of these coils which are outside. They just were looking into the impedance and Q factors. All these examples which you have seen here, I'm putting out of the mix and match table on our website, and you can find also the coupling factors at our tool REDEXPERT. I would like to show you also a good example why we have a good user experience and success of my mobile, like this one here. As you see, at the iFixit website, they disassemble this electric parts, and here we can see an iPhone 12, for example, and you see here in the middle is the receiver coil. The receiver coil in this picture, you cannot see it directly by how big it is, but you can imagine it's in the shape or in the size of 48 to 50 millimeters. As also the Apple engineers, they want to have a 1 by 1 area to increase the coupling and the efficiency, and you don't have to search for the working point. You just place it on top in any point and it will work. Which products we have and which you can support, we will support you. We as well, Würth Elektronik, have the broadest portfolio of wireless power coils in the market. You can look around in the global markets, different kind of competitors of us, but we have from very small parts up to very thin parts. We have like this one, combined coils for wireless power transfer and NFC. We have coil arrays, 2-3 coils. We have coils for high energy up to 200, 400 watts. We have small transmitter coils. So every wish you have, we can do. And we have on stock all parts. But also we do customer specific coils. Yes, we do. But what do you have to do if you want some kind of specific coils which are not fitting in your housing, for example? Please go to our website, fill in the inquiry sheet. We have an MOQ of 5K, include your sizes, your electrical parameters, mechanical parameters, and our engineering team will come back to you as fast as possible. Now I would like to jump into how you can realize it on your application if you have chosen the coil or you want to include wireless power technology in your application. One possible solution is our 200 up to 200 watt kit. This development kit, I don't want to read all these here, have a high efficiency, a very good and possibility to scale it up or down, and you are able to develop it by yourself. This is a development kit. It's not a ready to go and copy paste. It's a starting point to integrate the wireless power technology. We have on the transmitter side a full bridge and an active rectifier on the receiver side. In between, for sure, our coils. More detailed information you can find in our app note. If you would like to enable this system for IIoT, for Industrial Internet of Things, also this is possible with the system as we realized a new board, an LCD board, and we updated the software. The software which is needed, you can download on our website for free, and you need the Dave software from Infineon to download it, program it, and a debugger, which you can also buy at Digikey. As an example, we have a sensor for temperature. We measure this data and send by I2C bus the data to our receiver board. The receiver board is modulating the data and sending the data in band to the transmitter board. This modulation is ASK. We have from the transmitter to the receiver board a feedback loop, which is the data are also in band but FSK modulated. Now the transmitter demodulating the data and sending it by serial bus to our LCD board. Can be done, it's not a must, but it's possible. Here you can see the display, for example, the temperature, the pressure or acceleration or what kind of sensor you have. You can now transfer the data again by serial bus to our wireless node. This is a new featherwing board from our wireless connectivity business unit. These wireless nodes can be up to 65,000 pieces, but if you just imagine if you have a factory and there are a lot of sensors, so in this factory you can use up to 60,000 nodes and measure the temperature, the pressure, what you would like to know. With the proprietary WE transfer protocol with 2.4 gigahertz, the data are super secure and sending over to a Wi-Fi module. This Wi-Fi module is able to transfer this by a hotspot or by the company Wi-Fi internet connection to the cloud. In the cloud, you're able to show this data on a dashboard on your mobile device, and then you can create it at Azure or what else. Additionally, we have for sure also 15 watt development kits from the Renaissance solution. Also at this kit, we have a bidirectional data transfer, which is included by the protocol from Renaissance. And you can buy this kit. And inside of the kit, there is also a debugger included where you can program the data, which is possible transfer from transmitter to receiver and vice versa. All these documentation about how to do this for software side. You can find it at the website from Renaissance, and for sure also some manuals in our website where you can order the kit. This is based on a G 1.2.3. If you need additional information material, where you can get it and how you can who you can contact. First of all, your first address will be our website, Wireless Power, weonline.com Wireless Power. Here you can find everything what I have explained today, like the 15-watt kit, the 200-watt kit. There are other reference designs, the mentioned mix and match table, where to find the best coil pairing, and the link to our REDEXPERT website. There is an FAQ website for initial questions maybe you have, like the maximum distance, which power can be transmitted, and all other questions which will come up as mainly comes up. If there are any questions which you don't get an answer on our website, for sure, just contact our Wireless Power at weonline.com address, or for sure today at the chat. I would like to jump shortly to the mix and match table, as I mentioned before. The mix and match table, you have a transmitter receiver combination, and if you are choosing one combination with a green tick here, then you will click on it and you will be forwarded to our REDEXPERT. The previous clicked combination you can find here, the transmitter coil, this is the receiver coil, and here at the REDEXPERT side, you have a great, let's say, added values, which you will find the best solution. As an example, you choosing out the 205 coil because of maybe the current or the size or what else, and you see that the coupling is at 0.54. But as you see with this coil, transmitter coil, we will have other parts which are having a better coupling factor. That means the efficiency is better. Anyway, you can find here the values of the resonance tank for the receiver side, which you have to adapt on your schematic. We calculate the values and give you the figures, let's say the C1, C2, and C3, which we have tested on our side. So that means these are really values which are tested and which are working. Additionally, at the REDEXPERT side, which you will not find in the datasheet or in the online catalog, we have the permeability curves of the infrared materials. Yeah, additionally, if you want to more detailed information, you are welcome and to directly use our book. At this book, you will find all informations, basics about wireless power transfer, about magnetic fields. You can also read the 200-watt solutions and other reference designs, how they are working and what's going on over there. Arguments. Yeah, why you should use wireless power transfer technology in your system today. First of all, you have to choose for sure one of our parts. We have the broadest product portfolio, and you will find the best solution for you. If you cannot find it on the standard, we are able to do a customized solution for you. We have high performance and quality, high quality products. We are able to produce also in high volume, and we have supporting tools, as mentioned, the mix and match, REDEXPERT, or also the book. Now, I'm very happy if you have any questions and I can help out and answer your question as well, which popping up right now, or if you have any other topics from me. And I will hand over to Amelia again.
Okay, thank you very much, Cem, for presenting Very good presentation. We do have some questions coming in, and as he mentioned, if you do have any, simply ask them in the questions box. We're going to get to those right now. Our first question, is there a way to send power and data through the same interface? Also, is bidirectional communications possible?
Yes, so as explained in my training, the interface is just the two coils, and you are sending the data in band between the transmitter and receiver side. And so the general question, it's bidirectional from transmitter to receiver and vice versa. So yes, is the answer.
Excellent. Our next question here is, does this solution work even if one of the two coils is rotating, supposing a low rotation speed?
Mm-hmm. Yes, I will just take here my charger again. And if we have, for example, two coils and one is rotating and one is fixed, or both are rotating, it's no problem. The only point is if they are misaligned, or if you cannot do this misalignment in this way. But if they have one axis and they're rotating, this is possible, as the magnetic field will stay at the same way as they are not rotating. So yes, it's possible to do.
Excellent. Hopefully we were able to answer that question thoroughly enough. Our next question here is actually regarding the books. You have mentioned the trilogy of Wireless Power. We heard that there might be other books available. And maybe just for our viewers, where can we find both the trilogy and these other books, and what are they?
Sure. So then let's maybe, I don't know if this, I'm sharing my screen right now, Amelia?
Yes.
Yes, so just have a look on our website. Here we go. We see our reference guides called, and we have 6 books overall. And one of them is the trilogy of wireless power transfer, but I'd say our most famous, I think, is the trilogy of magnetics, which is coming up with the 5th edition. Also, we have it for connectors, an ABC of capacitors, ABC for power modules, and a brand new LT Spice 17 simulator book, which is, I don't know, maybe just 1 month ago we did an update for this. And some of these books, I'm not 100% sure which of them are also possible to get an ebook. So please just go on our websites, product services, reference guides, and you will find all the other books.
Yes, not all of the books are available as ebooks. I believe that they have just released, perhaps it's the LT Spice. Otherwise, I do know that Trilogy of Magnetics is available as an ebook, and we can actually include that link in the follow-up email if people would prefer that. Our next question, are the wireless power transformers using ferrite core, or are they coreless?
They are, let's say, in our product portfolio, we are using only with ferrites, with magnetic zinc or nickel zinc materials, which have the best shielding behavior against the environment, against the rest of the schematic and circuit, and which will focus the magnetic field to the transmitter and receiver side. So we don't have air coils. We only have with ferrite. Air coils are mainly used, let's say, for NFC, RFID products where the power level is very, very low in the milliwatts or microwatts.
Excellent. A couple more questions here. We discussed the rotating coils, but is there a rule of thumb for distance between the receiver and transmitter in function of power?
Sure. There is a distance. So we have, let's say, around about 5 to 10 millimeters for the inductive coupled solution. If you would like to increase the distance, the coupling is getting worse. And then, 2 things you have to do. You know that you have to send more energy to get it out of the system at the receiver side, or you have to increase. I will just show this maybe with my 2 rings here. So if the coils are bigger, for example, like this, and I have a smaller one, like that. So as bigger the area is as bigger as the magnetic field, which are standing out, and then you can increase the distances, right? But in general, it's always very hard if you have a huge distance. The stray fields are big, and then it's getting much more harder for your FCC or RED or other certifications EMI side. So in general, yes, it's possible. Efficiency getting down, but we are not recommending this to do.
And then our next question, you might have actually covered this. What is energy efficiency if coupling is poor?
If the coupling is poor at the Qi system, at less than 70% is this system efficiency, the system will shut down. So if I have, for example, again, my mobile and my charging station, and if the distance is increasing, at a specific point, the efficiency is lower than 70%, and the transmitter will shut down the efficiency. For sure, you can also make a proprietary system, as I mentioned, with the up to 200 watt development kit. Maybe you just accept, I don't know, 50% or 20% efficiency. This is also possible to do, but in general, yeah, you lose energy and you just strayed around. The question is if this is acceptable on your application. If yes, okay, you can do it.
All right. And our final question here, what development kits are available for low power solutions?
Low power, now the question is how much is low? So we have our 15 watt Renaissance, which was before IDT. Kit is up to 15 watt. That means it's not only for 15, it's up to 15. So that means in this case, you can use it also for 2 watts or 5 watts. But there are also special IC reference designs, for example, from Linear Technologies, which are now analog devices. They have also systems which are used for, I don't know, just, I don't know, smartwatches, for example, applications up to 2.5 watt. But also, I think, I'm not sure, but TI, I think they have also a 2.5 watt solution. So there are for sure lower power ranges possible, and that are compliant to the Qi, but again, Qi certified. They're all out of this Qi certification. So you can use this, but then you have to do all this EMI and other certification by your own.
Absolutely. I feel like we've come a long way since our first wireless kit, which was a 5 watt wireless
correct,
kit.
Yeah.
And,
a long time ago.
That was only just a few years ago. So we have come such a long way. All right.
That's right.
Well, thank you, Chem, for presenting today. It looks like those are all the questions. If you think of a question later or you want to reach out to us, that is perfectly fine. Simply email us at hereforyou@we-online.com. That is the email address where we will be sending you the follow-up webinar. You will receive the video on demand as well as the presentation slides. Don't forget to complete your design on wireless power on our website at we-online.com. We have everything for EMC, we have capacitors, we have inductors, and everything in between, we-online.com. And Chem, we will see you next week with our next webinar, which is actually the sequel, and it is Advanced Coil Knowledge on the 19th.
I'm happy.
I am very excited about that. And naturally, everybody can register online at we-online.com/webinars. I'm Amelia Thompson. Thank you so much for joining us today. If you want to see all of our upcoming webinars, check out our website. You can also follow our corporate accounts on LinkedIn, Twitter, Facebook, Instagram. You can also follow me, Amelia Thompson, on LinkedIn. But until next week, we will see you later.
Bye-bye.